Okay, so we are still in Unit 5, where we are, let me just adjust this a little bit, where we are talking about monomials and polynomials. And today we're going to talk about Lesson 9-1. And this is going to be adding and subtracting polynomials. And the first thing we're going to do is we're going to define these terms. We're going to define polynomial, monomial. We are going to know exactly what we are talking about. So the first thing that I want to talk about is monomial. Let's see, monomial is basically a single term. And it is, oh gosh, how do I want to explain this? So, it can be, a monomial can be a constant, okay, 12, that's a monomial. It can be a variable, just a single variable, x or x cubed, those are monomials. Or it can be a combination of both things. So it could be 12x. It could be 2xy squared. So you can have a couple of variables together because it's all this one unit of just multiplication. There is nothing else in there besides this multiplication, or we can also have it as division, c over 3. That is also a monomial. Now c over 3 is the monomial, but let's make a note here because we need to understand the fact that c over x is not a monomial. And what do you think the difference there is? Okay, what do you see? What is different there between the two? Can everybody see that this is a constant down there in the denominator, whereas this is a variable in the denominator? A monomial cannot have a variable in the denominator. Very, very important note, so please make sure that you star that because this will come up, I promise you. So, okay, so here we have talked about monomials, and now with monomials, we also talk about the degree of a monomial. Degree of a monomial. When we talk about degrees, we're basically talking about exponents. So let's say we've got 2/3 x. Okay, this is a degree of 1. Degree of 1. The reason why this is a degree of 1 is that the exponent to our variable is a 1. Okay, there isn't one, so that we can see, which means that the exponent is actually 1. This is a degree of 1. Now, if I have 7x squared y cubed, this is going to be a degree of 5. And in this case, we've got two variables, and each variable has an exponent. So in this case, what I'm going to do is I'm going to actually add those two to get the degree of 5, 2 plus 3. We do not count the exponents on our constants. So because those can actually be calculated out, so we don't count that. Like if this 7 was squared, well, I would just say it's 49. So the exponent does not become that important for the constants, so we only worry about the variables. And then finally, let's say we've got just a -4. -4. This could be any constant. It could be -273. It could be +1 billion. It doesn't really matter. This is a degree of 0. Okay, degree of 0. The degree of a non-zero constant is 0. Okay, so degree of 0. So understanding that, we're going to move on now to our polynomials. So first we're going to go ahead and define a polynomial. We've been talking about them a lot, so we might as well get a definition down here. So polynomial is going to be the sum or difference. The sum or difference of two or more monomials. So let's just look at, we've got like 3x to the 4th plus 5x squared minus 7x and plus 1. Okay, so this is a polynomial. Notice that it is made up of 4 monomials. So we don't really worry about, you know, the fact that there are 4 monomials, rather 3 monomials. We just call these, this is a polynomial. We can call it, if it had 2, let's just say, you know, here I'll use my giant eraser. Let's say that we only have 2. We could call this a binomial. If we only have 3, we would call that a trinomial. They are all still polynomial. It's kind of like that umbrella. So in this case, there are actually 4 monomials. When we look at the degrees of these monomials, what we see is that we are going to use the degree of the highest exponent. So in this case, we're looking here at this 3x to the 4th. Okay, the x to the 4th has got a higher exponent than anything else that's in here. Of course, the 1 doesn't have an exponent on because it doesn't have a variable. So this is going to be degree of 4. And what we're going to look at is that we have specific terms for these things. So we're going to kind of build a little bit of a chart. So let's go down here. We're going to build a little bit of a chart, and we're going to have our polynomials here, polynomial. Okay, we will then separate that down by degree. We will then have our name using our degree. Sneak things in. And then we will have number of terms. Okay. And then finally, our last column is name using number of terms. Okay, so this should be something that you have in your notebook as we go through, you know, be filling it out. I think that you'll see that it's very understandable. So we're going to start with 7x plus 4. Now, looking at this, we have just the one variable. We've got 2 terms. so kind of jumping the gun, but I always like to look at it in terms of the fact that there are two terms. I'm going to come over here, put that there are two terms. Now, our variable x has a degree of an exponent of 1, so this is a degree of 1. Now, using that degree, name using degree, well, this is linear, and I'm hoping that you're looking at this thinking, yeah, that looks an awful lot like mx plus b. Mx plus b. This polynomial is a linear polynomial. Okay, it has two terms, and we call this a binomial, as I referred to that earlier. Okay, that's a binomial. Then we're going to go to our 3x squared plus 2x plus 1. We have three terms here. Notice I do like to jump around. Our highest degree here is 2. And this one, because of that square there, this is called a quadratic. Has three terms, so this is a trinomial. Using our Latin prefixes here of bi and tri. Okay, so 4x cubed. 4x cubed. Looking at this, there's only one term there, okay? But it's a degree of 3, and we call this cubic, okay? And one term, this is just a monomial. One single term. Okay, moving on to 9x to the 4th plus 11x. It is two terms. Our highest exponent is a 4. This is 4th degree. And here we are once again looking at two terms as we've written here. So again, this is a binomial. And then finally, we'll end with a 5. Well, okay. As we saw before, our 5 is a degree 0. Okay, we call this a constant. We need to make sure we know that. There's only the one term, and it is a monomial. Now, we didn't look at anything that was a strict polynomial, but anything that goes above the 3 terms is just going to be labeled a polynomial. So let's say I was looking at 3x to the 4th minus 4 plus 2x squared plus 5x to the 4th, okay? First thing that I want to do with something like this is say, whoa, wait a minute. This isn't even in good order. So the first thing I'm going to do is I'm going to put it into order. So I'm actually going to say 3x to the 4th plus 5x to the 4th plus 2x squared minus 4. I'm going to go ahead and combine these like terms. So I'm actually going to have 8x to the 4th plus 2x squared minus 4. Okay, what I have here then is actually a degree. I'll put it over here. My degree is 4. So this is, we would call it 4th degree. And there are 3 terms, so this would be a trinomial. Okay, hopefully everybody understands that. Let's do a couple of these before we move on to actual adding and subtracting. Okay, so let's start with 6x squared plus 7 minus 9x to the 4th. Once again, I am going to ask you to always put these in proper order. The proper order for this is negative 9x to the fourth plus 6x squared plus 7. Notice that my sign goes with the movement of my monomials, okay? So I have a fourth degree and I have a trinomial. Okay, I'm looking here and I'm looking at the fact that I have 3 monomials. Okay, let's look at another one. Let's look at 3y minus 4 minus y cubed. I really wrote that badly and I'm sorry. Y cubed. Okay, putting it in proper order, remembering to keep those signs that are in front of it, we get negative y cubed plus 3y minus 4. We always make sure that they are in descending order of exponents. So if I didn't say that before, which I don't think I did. Okay, so this is cubic because I have my degree is 3. So I'm going to call this cubic, and there are 3 terms, so it is a cubic trinomial. Okay, and hopefully that is making really good sense to you. Okay, so let's talk now about adding and subtracting polynomials. Adding and subtracting polynomials, simply you are taking 2 groupings of monomials and adding them together. So basically you are combining like terms just on a more major, in a more major way. I'm going to show it vertically. Some people prefer horizontally. I just think that it makes more sense vertically. Makes more sense for me, so it's easier for me to show it that way. Let's look at combining 12m squared plus 4, and we are going to add to that 8m squared plus 5. Okay, so when I put this together vertically, I make sure that things that are alike are on top of each other. So in this case, I've got 12m squared plus 4. Now, this 8m squared, I'm adding this 8m squared plus 5. And notice how this lined up really nicely, so I didn't have to worry about skipping spaces or anything. 4 plus 5, this is a positive 9. And here 12 plus 8, both a positive, is 20m squared. So my answer is this 20m squared plus 9. Pretty simple. They're not always that simple, but we'll keep looking at a couple more. Let's look at r squared. Actually, that's a t. I'm not going to do that. I'm going to do x squared minus 6 plus 3x squared plus 11. Okay, so once again, stacking them the way we did before, x